Biomass is often used to supply high-temperature district heating networks. In this video, I show you how to plan a district energy system with a biomass boiler using nPro. Hi and welcome to this nPro tutorial. I'm Marco, and in this video we will go step by step through the dimensioning process of a local energy system with a biomass boiler. Let's dive into it and see how that works in nPro.
In the tool on the left-hand side, we can click on Energy Hub. Then we select a new project template. For this, I will choose the biogas CHP unit and biomass boiler. But we can also choose any other template because we can modify the system completely in this view here. I will deselect the cooling units and I will change the fuel of the CHP. For this, I go into the CHP settings. I will select natural gas, say OK. And now I will also deselect the feed-in of electricity in the electricity grid settings. And I will increase a little bit the natural gas price here. Now I click on Size Technologies, and now we have the optimal sizing for the CHP, 250 kilowatt electric, and the boiler 320 kilowatt thermal, and we have a heat storage of 43 cubic meters. For this scenario, we didn't define any demand profiles, and we just took the example profiles that are already in nPro, but of course we could upload our own profiles as well. So we could change now the sizing, and I will do this, for example, for the biomass boiler, and then we click on Simulate System Operation. And if the operation is done, we will see how the components are operated over the year. First, we see the energy flows. If we go with the mouse over one of the lines, we can also see the energy quantity. And we see here that most of the heat demand is covered by the CHP unit, and the boiler is used as a peak demand to cover the peak demand. And about half of the electricity comes from the CHP and the other half from the electricity grid roundabout. We will see this later. On the bottom, we can visualize the operation of the CHP. I click on Heat Map, and here we have a listing of the hour of the day against all days of the year. So we see in summer, the CHP is not running so much. It's more running in the winter and in spring and autumn. We can visualize the boiler as well. And here we see that the boiler only covers the peak demands, for example, during the cold period here in February. If we have the KPIs on the right-hand side in the table, so the capacity, how much heat and fuel and so on is needed. And a summary of the energy system can be seen in this view. We have, if we go to electricity, then we see that 45% of the electricity comes from the CHP unit and 54% comes from the electricity grid. For the heat generation, we see that the CHP covers 84% of the heat demand and the boiler 16%. Also, the CO2 emissions are listed here and the primary energy for electricity import, natural gas and biomass. The factors for emissions and primary energy factors can be changed in the optimization settings. If I click on economic results, we can see that this system has revenues which are higher than the costs, so the system is profitable. We have the cash flow table with the net present value after the system's lifetime, so 20 years, and here it is positive. We also have tables regarding the investment costs, the energy costs, maintenance and operation costs, and here in the revenue table we have the revenues for the demands. So the system or the operator of the system will receive a revenue for every kilowatt hour that he can cover. And in this case, we assumed 20 cents per kilowatt hour, but we can change this to 10 cents per kilowatt hour. And then the calculation updates immediately. So we will go up, and then we see, oh, the system is not profitable anymore. But let's increase the electricity revenue step by step by 1 cent per kilowatt hour, and then we can see here on the top that we would actually reach the profitability at this point, and this would be here now 13 cents per kilowatt hour. Of course, we could also modify the revenue of the heat demand. I click on OK, and then finally I want to mention that you can also download all the results as Excel sheet, where you have all the profiles of the CHP and the biomass boiler and the electricity grid and so on. And you can do further analysis. We also have the KPIs and the economic results in the Excel sheet. And you can do further investigations there.
If you have any questions or remarks about this video, feel free to leave a comment. If the video was helpful for you, please give us a like and subscribe to our channel. Thank you for your interest, and see you next time.